Alright, so for today we're going to be talking about density. Despite common belief, it's not where the bears live. So the first thing we got to do is talk about what it means. So let's start with a formula. I know you love formulas. So this is what the formula for density is. Let's talk about what the letters are. Let's start with M. M stands for mass. Alright, what are the units that we typically use for mass? Well, you've got two choices here. We're going to use kilograms in physics, but it is not uncommon that you'll see sometimes grams being used, especially for density, because we're kind of still in chemistry territory for now, but we'll get out of there soon, don't worry. Hey, when we're talking about V, V stands for volume, because it's capital V. What's volume going to be measured in? Now, here you got lots of choices. It could be in liters, it could be in milliliters, it could be in cubic centimeters. Now, a cubic centimeter is the same thing as there, or it could also be in a cubic meter. Okay, depending on the type of problem, you'll see any one of those. All right. Now, you're not going to have to worry too much about conversions here. You're typically just going to give your answer how they gave you the information. All right. This last guy over here, this is density. Now, the letter isn't a P. I'm sorry. It's a rho. It's a Greek letter. Rho looks like that. P kind of looks like that. I know they look the same, but I'm doing the best I can with what I can give you. Now, the units for density are going to just be a combination of those. So it's mass divided by volume. So you're going to have kilograms divided by meter cubed. That's typically the physics version. Or grams divided by centimeters cubed. That's typically the chemistry version, but you can do any mismatch, and it's not going to be wrong. It's just going to be a different unit. But stick to what the question gives you. Keep it simple, right? So let's do a practice problem here. So we're going to fill a hot tub up with mercury, because that is what the cool kids do. And then mercury has a density of around 16,000 kilogram per meter cubed, and the hot tub is 1.5 by 2 by 1 meter. What is the mass of mercury that we'll need? So whenever you're starting something like this, we're going to start with your equation here. So rho is going to equal M over V. Once we have that written down, let's solve it for what we're interested in. We're solving for mass, so we know that mass is going to equal rho times V. All right, and then we're just going to plug everything in because it's easy like that. Density, we know what that is. It's 16,000. And then what we're going to do is we are going to find the volume. The volume is 1.5 by 2 by 1. So altogether that would be a 3. And 3 times 16 is going to be 48 with 3 zeros at the end. All right, and we know the units for that. The units for that are going to be in kilograms because that's the units that we have for mass. All right, so that's it, and then you're done. All right, let's look at the next thing here. So when we measure density, we're going to do a lab, sort of, online lab, to measure density. What you're typically going to be using for this is a cylinder, a graduated cylinder, measuring the difference between them. So when you have a graduated cylinder, it's going to give you lines here, tell you the milliliters. We'll say that this one is 34, this one is 35. And they'll have some lines in there, something like that. Now, what we're going to do is we're going to drop our object, whatever it is, in, and the water's going to go up, right? Whoop. So based off of that, we can figure out what the density of the object is, or what the volume is, because right, pushes the water up, so we can figure out the volume. Oh, I need some lines. Oops, too many lines. All right, so this guy right here, let's get a measurement. So this guy is going to be 35 right? It's above 35. Remember, where do we measure? We measure from the bottom, the bottom, the bottom. So this is going to be 35.8, right? Right about there. You could say 80 if you want. That'd probably be more accurate anyways, because we have the lines there. And this reading right here, the bottom, the bottom, the bottom, is going to be 34.40. So we're going to subtract these guys, right? Figure out the difference, because this is equal to the volume of the block that we dropped in there. So we're going to have a 1.40 milliliters. Now what we're going to do is we take our block and we put it on a scale. And let's say that we put it on the scale and it was 23.16 grams, all right? So if we wanted to figure out the density of the block, we're going to have to use our fancy formula here. So our density is going to equal mass divided by volume. We don't have to do any rearranging here. Our mass is 23.16. Our volume is 1.4. Typing it into our calculator. Oops, divide by 1.4. So we're going to get 16.54. Now, we have to think about it. Is that the right amount of sig figs? No, it is not, because we have 4 sig figs on top, 3 on the bottom, right, because it's 140. So we're going to have 16.5, and then we're in grams per milliliter, and that's what we'll be looking at for our answer. Now, this is the kind of thing you'll be doing in your lab, so it's a little shorter today because you're going to have to do that. All right, go have fun. We'll see you later.